Alright guys, today we're going to talk about neutralization reactions. Now, neutralization reactions are what happen when you put an acid and a base together. So, when you put an acid and a base together, we'll just say A and B, you'll produce two things. You're going to produce a salt and you're going to produce water. Alright, so those are the two things you're going to produce. So, we're going to put one of these up here right now, a real one, and show you what it looks like. And so the first thing we're going to do, let's do our acid. So, the acid I'm going to pick is nitric acid. So, HNO3, nitric acid. Alright, we're going to react that with a good strong base, let's say potassium hydroxide. So, KOH. Alright, so we have a strong acid, we have a strong base here. They're going to react in a neutralization reaction. So, what's going to happen? Well, this is a double replacement reaction. So in a double replacement reaction, remember, our cations are going to flip places. So let's see what happens. So, we got the potassium from the hydroxide, cation, is going to flip places with the hydrogen from the nitric acid. Which makes, well, when K and NO3 come together, you gotta remember, these are ions, so it's a K plus and an NO3 negative. Well, those charges will cancel out, so we're gonna have K NO3. That's gonna be our salt. Alright, now, you gotta get used to this. Salt is not just sodium chloride. Salt basically are ionic compounds. So we have our salt and our hydrogen and hydroxide are gonna get together. Hydrogen's a plus, and hydroxide has a 1 negative charge. Those will cancel out, making it HOH, and it's okay if you write that, or you can rewrite that. I like writing it as H2O, our water. So, acid and base give you a salt and water. Give us room here. I'm going to put another one up, and what I'll do is pause for just a second, give you time to pause and work it. Then you can push play and see if you got it right. So, another one we're going to put up here. Let's see. Let's put hydrochloric acid, strong acid. Plus, this time, let's say magnesium hydroxide. Alright, what are these going to produce? Okay, if you've paused, and hopefully you're back now, and we'll see what we produce. So once again, magnesium is going to switch places with hydrogen. So magnesium chloride get together. Got to be careful here. Magnesium has a 2 plus charge, and chloride just has a -1. So we're going to need 2 chlorides to cancel out. So MgCl2. Magnesium chlorides are salts. Alright, and we're going to make water again. This H and this OH are going to get together. So we're going to know that every time. We're going to make water. Now, we still have to balance equations here. So, 1 hydrogen and then 3 total over here. Only 2 over here. 1 chlorine, 2 chlorines. So, let's put a big old 2 in front of this. So now I have 4 hydrogens. Alright. And if I put a 2 in front of over here, now I've got 4 hydrogens there. 2 chlorines, 2 chlorines, 2 oxygens, and 2 oxygens, 1 magnesium, 1 magnesium. It's balanced. So, if this is the equation you got it right. Alright, we're going to move on. Now, neutralization reaction does not mean you're going to get a pH of 7 when you put these together. Reason why is this. When you put strong acids and strong bases together, like we just did, so let's go back to the one we did. We did HNO, that's not an H, let's try again. HNO3, strong acid, plus a strong base. We got potassium nitrate and water. Alright, so we did a strong acid and strong base. Here's what happened. So we got strong acid, you have a strong base, you have a neutral salt. However, let's say you have a weak acid. Let's do this one, HC2H3O2, which you should know is acetic acid. This is a weak acid. Plus, let's put it with a strong base, such as sodium hydroxide. When you do this, you're going to still produce a salt and water. So sodium's going to switch places, hydrogen. So we're going to have NaC2H3O2 plus our water. When this happens, we have a weak acid. We have a strong base. And this time the salt is not neutral. Since we have a strong base and a weak acid, we actually make a basic salt. If you flip this around and you had a strong acid and a weak base, you will make an acidic salt. All right? And that's how neutralization reactions occur. With all that being said, we can look at an actual calculation with neutralization reactions. So here's what we're going to do. I'm going to grab a sheet real quick so I know what I'm writing down. All right. So how many moles of HNO3 will it take to neutralize 0.86 moles of potassium hydroxide? So we already did this reaction before. We know HNO3 plus KOH will give us KNO3 plus H2O, and it's balanced. All right, this is a simple stoichiometry problem. To neutralize, we know that they're going to get together and react completely. So if I start off with 0.086 moles of KOH, well, what's neutralizing it? The acid here. So I want to cancel out moles of KOH, potassium hydroxide, and go to moles of HNO3, our nitric acid. Well, mole to mole, we look at the coefficients. They're 1 and 1, so this is an easy one. I get 0.86 moles of nitric acid. And there we go. Neutralization reactions with some stoichiometry. Doesn't get any better than this.